Okay, so we previously looked at proving two triangles congruent using theorem side, 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 and side, angle, side. Now we're going to be looking a little bit more involved with angles. These are two theorems, angle, side, angle, and angle, angle, side. So in both of these cases, I would be proving that triangle ABC is congruent to triangle DEF. Again, looking for that correspondence between the two. For angle, side, angle, it would be two angles congruent. So angle D is congruent to angle A, and angle E is congruent to angle B, with a side in between. So two sides, two angles congruent with one angle between. It is important that with one side between, sorry. It is important that that one side is between the two angles. It cannot be, apart from them. So I can't have angle, angle, side, because that would be angle, angle, side, which is right here. So it is two angles with one side not between. And there's only one way for that to happen. So here if I have angle A is congruent to angle D, angle B is congruent to angle E, I could say that side AC is congruent to side DF. Or I could say BC is congruent to EF. Either one of those sides is not between the two angles. So that means that it is angle, angle, side, and the two triangles are congruent. So let's take a look at this and look at some examples. So here I have two triangles. And this is actually a really good example too, because notice these are kind of rotated around. So that means that angle M is congruent to angle S. We can't be confused with this. We need to rotate this triangle around. So just something to be aware of when we go through our proof. So we're going to break this down with statements and reasons. Statements and reasons. Oh, and let's start with our given. So angle M is congruent to angle S. Angle J is congruent to angle R. And MP is congruent to ST. Well, look at that. I have an angle here, and that's an angle there. I have two angles being congruent with a side that's not between them. So that's actually enough to say that JMP is congruent to RST, triangle RST. And that's actually because of angle, angle, side, all in step one, right? Angle, angle, side. If I had shown that RS and MJ were congruent, then that would be angle, side, angle. But because this side is not between them, I just have angle, angle, side. And that's enough to prove it. Simple enough, right? Of course, I'm not always given everything. So here, I'm going to have my statements and reasons. And let's start with a given. So CP bisects BCR and also BPR. And let's also say that CP is parallel to RP. Okay. Well, if CP is the bisector for BCR, that means that this angle here is equal to that angle. So I can say that angle BCP is congruent to angle RCP, and that is the definition of angle bisector. But also in that same step, I can also say that BPC is congruent to RCP. Right? Actually, I don't even need that parallel line. That parallel line, if we wanted to, we could show that these angles are actually congruent, and then that would give us well, that would give us some other things, but we don't have to worry about that because we actually have enough. We can say that CP is congruent to CP, and that is, of course, the reflexive property. And now I actually have enough to say that triangle BCP is congruent to triangle RCP, and that is because angle, side, angle. So I got the first angle in step 2, the side in step 3, and actually the second angle in step 2. Angle, side, angle, which is right here. So, whoops, this picture went away. Oh, no, it didn't. Angle, side, angle. So here, if I look, I have angle, side, angle, angle, side, angle. This is a nice proof showing that. All right, then I have these triangles here. So, reasons and statements. Let's start with that given. So angle N is congruent to angle L, and JK is congruent to MK. It's all given, and it's nice that they marked that all up for us. Well, look, I have vertical angles, so I can actually say that angle JKN is congruent to angle, so JKN is going to be congruent to angle MKL. MKL. Please note that that order is important because if angle N is congruent to angle L, I should have them in the same position. So just watch out for that. That's more important with triangles than it is with angles. So when we actually prove that, it's going to be important. So here, vertical angles are always congruent. And so we have enough to say triangle JKN is congruent to triangle MKL, because if I look, I have angle, angle, side, that non-adjacent side to both angles. So that's angle, angle, side. And I got my two angles, so 1 and 2, and back to 1 for the side. For the next proof, statements and reasons, let's start off with given. So AB is congruent to CB, angle A is congruent to angle C, and DB is the bisector of ABC. And that's all there, but DB is the bisector for angle ABC, so that means that this angle is equal to that angle, so we can say angle ABD is congruent to angle CBD, And that is going to be because the definition of bisector now, if I actually look, I can say those two triangles are congruent. I can say triangle ABD is congruent to triangle CBD, and that's because of angle, side, angle. So I got the first angle in step 1, the side in step 1, and then the angle step 2. But notice, that's not what I was trying to prove. I was trying to prove that side AD is congruent to side CD. Well, actually, I can say that because of CPCTC. Corresponding parts of congruent triangles are congruent. That means when I have two congruent triangles, all the angles are congruent and all the sides are congruent. So if I can show that the two triangles are congruent, then I can just say, hey, these two angles are in the same position, so they must be congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. So that's it for these two proofs. So, right now we've had 4 main theorems to look at to prove angles congruent. Side, 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 angle, angle, and angle, angle, side. So just make sure you keep getting practice with these, and sometimes you can actually prove them in multiple ways. And it's a good idea to try and look for all the possible ways to prove them.